Hey there, scientists! Today we're learning about one of the vocabulary features of science writing, nominalisation. Like any other subject, we have particular ways of communicating our knowledge and understanding. A quick look at the communication tree for science reminds us that there's a lot to think about when we communicate as scientists. Today, though, we're going to be focusing on one particular branch of communication. We're going to look at the ways that scientists determine their register through the use of something called nominalisation. Before we really dive into nominalisation though, I want to talk about one of the most important aspects of scientific study. That aspect is the way in which scientists often focus on understanding the processes in the world around us. Here we have two processes that some of you might recognise. On the left, we have a cold can of Coke covered in droplets of water. On the right, we've got a petri dish full of bacteria gone wild. As scientists, we seek to understand the processes happening in moments like these ones. So how do we do that exactly? Well, this is where we shift gears a bit and start off with something called suffixes. These are groups of letters that change the meaning and function of words. One of the ways that they change meaning is when we use them to communicate tense, telling the audience when something happens. So let's have a quick look at tense using one of the processes we saw earlier with the Coke can. If we just add an S or an ES to a verb, we show the audience that something is happening in the present. So if we're sitting watching that Coke can, we can say that the water vapor condenses on the side of the can. If we sit and watch it continuously and notice that it keeps happening without stopping, we might say that the water vapor is condensing on the side of the can. We use that ing ending. Then, once we've decided that the process is finished, we might use a D or an ed ending and say that the water vapor has condensed on the side of the can. The next day, when we write our report, we will write that the vapor condensed on the side of the can. Creating tense isn't the only thing that suffixes can do though. We also use suffixes to turn other words into nouns. This is not really changing the meaning of the word, but it is changing the function, the way we can use it in a sentence. So let's look at our Coke can again. The process we're observing is water in warm air meeting a cold surface and transforming from a gas into a liquid. That's a bit of a mouthful though, when we have a nice precise word like condense. So let's look at how different suffixes change the function of this one word. Adding s, ing, or ed means we can use the word as a verb to show when and how something happened. We can also use these suffixes if we wanted to use the word as an adjective to describe something. For instance, we might write the condensed droplets of water formed after a certain amount of time, or that the condensing droplets tend to trickle down the side of the can once they get too heavy. These suffixes, though, are all about telling us when something happens. We can turn the word into condensation through the process of nominalisation. This keeps the meaning, we're still talking about droplets on the side of the can, but the new suffix changes the way we can use this word. Now we get to use it as a noun. This is what the process of nominalisation is all about, turning words into nouns. Now there's a few ways that we can nominalise, but adding suffixes with specific meanings is one of the main ways we do this, and we use it a lot in science. So let's have a look at some of the different suffixes, what they mean, and some words we might encounter in different areas of science. Firstly, we have the suffixes ation and ment. Both mean the process or result of something. So in biology, a word like reproduction is the process or result of reproducing. Movement is the process or result of moving. Secondly, we have the suffixes j, ns, uri, and ism. These mean the same as the last lot, but they all start with vowels. In physics, voltage is the process of electrical pressure. Resistance is the process or result of resisting. Magnetism is the process or result of something being magnetized. And lastly, we have the suffixes ity, ness, si, and itude, which all mean the state or quality of being something. So in chemistry, conductivity is the state of being able to conduct electricity. Hardness is the quality of being hard. And being able to resist pressure. Magnitude describes the size of something. Nominalisation helps us label and identify the processes that we observe in science. Here we see the biological process of a parent bacterium creating new offspring. They reproduce, they're reproducing. The reproduced bacteria reproduce more bacteria. We observe a reproductive process. We've got a different suffix, tive here, which has been added to create a different type of adjective. This one means the function of something. So reproductive means the function to reproduce. Then if we nominalize by adding tion, shun, we get the word reproduction. So this is how we nominalize. Why do we do it? What's the point of it? Well, it's actually one of the key features of communicating in this subject. And there's a few reasons for that. First of all, nominalisation is all about focusing on the natural and non-natural processes that scientists often seek to understand. Additionally, it formalises your writing because the nominalised forms of words are often more technical than their everyday counterparts. So let's take a quick look at nominalisation in action. At the top, we've got our original sentence, something straight out of a prac report. We noticed that when the warm air collides with the can's cold surface, it loses heat and it condenses into water droplets. So this sentence has 4 clauses requiring 4 verbs. This means there's basically 4 layers to the sentence. Through nominalisation though, we can turn these 4 clauses into one. The collision of warm air with the can's cold surface causes heat loss and condensation into water droplets. We replace the 4 verbs with one that identifies how one process causes the other, and the original verbs all get nominalised and turned into nouns. Collides turns from a verb into collision, a noun. Loses becomes loss. Condenses becomes condensation. And then finally, we delete that reference to ourselves and start the sentence with the process itself. This really helps to create an objective, formal tone in our writing. Out in the wild, you'll encounter nominalisation in many places. A good example is Wikipedia. Here's a section from the Wikipedia page about bacteria. Nominalisation is used in the subheading and throughout the paragraph, as you can see here highlighted in yellow. If the nominalisations are a bit unclear though, we can work backwards to figure out what the base words mean. This is something called reverse nominalisation, and it's a reading strategy that we can use to help us understand scientific texts. Reproduction is the nominalised form of reproduce. Division is the nominalised form of divide. Formation, the nominalised form of form. And protrusion is the nominalised form of protrude, which means to stick out. So let's finish off with a quick summary. Nominalisation is the process of turning other words into nouns, often through the use of suffixes. Scientists use it to focus on the processes that they're observing and to formalise their writing. So next time you read something scientific, keep your eyes peeled for those little suffixes because they might be hiding a process behind a noun.